The next topic that we have to discuss is electrical flux for a closed surface. See, what do you mean by this electrical flux for a closed surface, for any closed surface? See, here also we are going to consider a non-uniform electrical field. So, let us take like this. Consider a non-uniform electrical field. Non-uniform electric field. What is this non-uniform electric field? See, if I am drawing a non-uniform electrical field, that non-uniform electrical field is of any shape or of any line like this. That is, they are not considered to be parallel. So if I am taking this non-uniform electrical field like this, and inside this non-uniform electrical field, I am going to consider a closed surface. What we have discussed in the previous case is an arbitrary surface. Whether it is closed or not, it is an arbitrary curved surface. But here it is not the case. Here we are going to consider an closed surface. In that closed surface, inside an non-uniform electrical field, what is the value of the flux available? The value of the flux available may be of three types. The value of the flux available may be negative. The value of the flux available may be positive, or the value of the flux available may be zero. So I have to explain when this value is negative, when this value is positive, and when this value is taken to be zero. That we have to consider. So, in order to consider that, let us consider a single electrical line passing through the closed area. So, I am taking that closed surface like this. In this closed surface, I am taking a single line which is passing through this, single electrical line passing through this. So, that line is entering here. Then it is inside this closed surface area, it is going on like this. And while leaving, it is going on. Okay, then we are calling this electrical line as E vector. Now, for inside this closed surface, what is the electrical flux? So, in order to calculate the electrical flux, first of all, let us consider the general formula. In general, the electrical flux through a closed surface is given by, flux phi of E is equal to integral of E vector into dA vector. This is what we have studied in case of curved surface. If you are taking the surface as the closed surface, then while writing this integral equation, you have to put and close this round a surface here, or we have to put a round in the integral sign. See, if you are putting a round, if you are putting a round in that integral, it represents closed integral of. So the integration must be taken within this closed surface, or we can say it is considered as surface integral. That is, the integration should be taken over the surface. So, when I am considering the general equation for the flux in this closed surface, the flux available in this closed surface is phi of E. While writing, I have to write it out as closed integral of. So, while writing the integral, you have to put the integral sign and put a round, and then you write E vector dot dA vector, or we can say this as closed integral of E into dA into cos theta. This we are calling it out as the total flux that is available for the closed surface. This total flux that is available may be positive, or may be negative, or it may be zero. How we can able to get this? So in order to get this, I am considering two small areas in this closed surface. See, here I am taking a small area, and similarly here also I am considering a small area. If I am dropping a normal here, that normal drawn will be along this direction, n cap, or I can write dA vector. If I am dropping a normal here, then that normal drawn will be along this direction. So it is again dn or dA vector, or I can write it out as n cap. Now you consider the angle between the normal drawn and that of the electrical lines of force. When I am considering here where the electrical lines of force is entering this closed surface, the angle is obtuse. That is, angle is theta. Angle is angle between the normal and the electrical field lines. We have defined it as theta. So the theta will be greater than 90 degree, or it is considered to be greater than pi by 2 radian. Similarly, when you are considering this point where the electrical lines of force is moving away from that of the surface, the angle between the normal, the normal and the electrical line of force, that is theta, is considered to be less than 90 degree, or we can say it is less than pi by 2. Now it is very clear. You see, if theta is greater than 90, then you will be getting the value as what? Then you will be getting the value as negative. Flux will be negative. If you are considering the value of theta less than 90, then the value of flux is considered to be positive. So here the flux is positive and here the flux is negative. If the angle theta is equal to 0, or if you are considering theta is equal to 90, what will happen? If the angle theta is 90 means electrical lines of force and the normal drawn are perpendicular, or the plane is parallel, then we can say theta 90, automatically cos 90 will become 0, then flux will be equal to 0. So the three concepts, that is when the flux will be positive, when that flux will be negative, and when the flux is considered to be 0, we have to write it out. So in the diagram I have explained. Now I am writing. See, from the diagram I am writing it like that. From the diagram, I can say angle between, angle between the E vector, that is the direction of electrical lines of force, and the normal drawn. That normal drawn is dA vector. If it is less than, see on the left hand side it is greater. So let us consider like this. If it is greater than 90 degree, that is we are saying theta greater than 90 degree or greater than pi by 2 radian, then we can say the flux available phi E is taken to be negative value, or considered to have a negative value. Similarly, let us consider this as the first point. Similarly, let us take the second point. What is point number 2? See, when you are considering point number 2, again let us write similar part. Angle between, if you are considering like this, angle between E vector and dA vector is less than 90 on the right hand side. That is, what happens? Theta less than 90 degree or theta less than pi by 2 radian. Then we can say the flux available phi of E is considered to be a positive value. Similarly, you can state the third one also, when the flux will be equal to 0, that also I can write. The third one, the flux phi E will be equal to 0 if angle theta equal to 90 degree or pi by 2 radian, or we can say it out as pi by 2 radian. This is how we can able to calculate what? This is how we can able to calculate the value of flux in case of a closed surface. See, we can conclude. So we can write the conclusion in another way also. How we can write the conclusion in another way? See, while you are considering the diagram, I have told while explaining the diagram, see, in this closed surface, at this end, the electrical lines of force is entering the surface. You see, at this position, see on the left hand side of the diagram, at this position, the electrical lines is entering the closed surface, and at this point it is leaving the closed surface. So I can write the electrical flux is considered to be negative when the electrical lines of force is entering the surface, and I can say the electrical flux is positive when it is leaving what? When it is leaving the closed surface. That was the conclusion that I can write these values in another form. So what is the conclusion that I can write it out in another form is, in general, I am writing here. See, in general, the flux phi E is negative, that is on the left hand side is negative if the electrical field line, if the field line or the electrical field line is entering the closed surface, and the value of flux phi E is taken to be positive if the electric field line is leaving what? Is leaving the closed surface. This we are considering it as the electrical flux for a closed surface. Hope you should have understood this. We can summarize. See, what is the topic that we are going to learn here or in this video is the electrical flux for a closed surface. See, when you are considering the electrical flux for a closed surface, first of all, what I have considered is, I have considered a non-uniform electrical field. See, in order to get that non-uniform electrical field, I have taken the lines drawn in an unparalleled way. So this represents, these lines that I have drawn here represents the non-uniform electrical field E vector. Inside this non-uniform electrical field, I have considered a closed surface. I have to calculate what is the total flux available for this. The total flux available for this closed surface may be positive, or it may be negative, or it may be zero. So how I can able to get this? In order to explain this, what I have considered is, I have taken the another diagram. See, what is the next diagram? I have taken the closed surface, and instead of considering all these electrical lines, I have taken a single electrical line that is passing through that closed area. That single electrical line that is passing through the closed area is entering at one end and leaving out at the other end. So, in order to get the electrical flux for this closed surface due to this electrical field, general equation I have written here. In general, electrical flux through the closed surface is given by phi E is equal to closed integral of E vector dot dA vector. See, while studying the previous concept, we have written this flux phi E without this round in the integral. While you are studying the curved surface, we have written the flux available as integral of E vector dot dA vector. But when you are considering the closed surface, we are writing integral within round. That we are calling it out as the closed integral or the surface integral. That integration should be taken over this closed surface. That was the meaning. So we can write phi E is equal to, for this closed surface, total flux available is closed integral of E vector dot dA vector, or we can write closed integral of E into dA into cos theta. This we are calling it out as the electrical flux for the closed surface. There is now we have to say the magnitude of this electrical flux may be positive or may be negative or it may be zero then. So in order to explain this, I am again considering this diagram. So in that diagram, at the entry part, I am considering a small closed surface dA. If I am dropping a normal n vector or dA vector, the angle between the normal drawn to that surface and the electrical line is greater than 90. The angle is obtuse. Similarly, when you are considering here on the leaving side, the electrical lines of forces leaving the surface, when I am dropping the normal for that closed surface, the angle between the normal drawn and the electrical field is less than 90. So if it is greater than 90, flux is negative, and if it is less than 90, flux is positive. You can very well apply this value in this equation. That is, what about the value of theta, whether it is greater than 90 or if it is less than 90. Using that, you can able to get the value as positive and negative by considering the quadrants, first quadrant, second quadrant, third quadrant and fourth quadrant in trigonometry. Similarly, from the diagram, I have written it here. The concept I have written it here. What the result that I have written, what I have told that, I have written it here. You see, angle between the electrical field E vector and dA vector is greater than 90 degree, then we can say flux is considered to be negative value. Similarly, when I am taking the angle between EA vector and dA vector is less than 90, then flux is considered to be positive. When you are considering phi E is 0, that is flux available in that closed surface is 0 means the angle between the normal and the electrical lines of force is 90 degree. That is, the plane is parallel, or that area, plane of that area is parallel to that of the electrical field. So we can write these values in another form. How I can write this in another format that I have given it out as conclusion. In general, we can say that the value of the flux phi E is negative if the electrical field line is entering the closed surface, where theta is considered to be greater than 90, and the flux value is considered to be electrical flux phi E is positive if the electrical field line is leaving. While leaving, the angle theta is less than 90 degree. So that is what we are explaining here with the help of the diagram as the electrical flux for the closed surface. Hope you should have understood this. Thank you. Let us meet in the next video.